Dear children, today we will study the third chapter, that is square and square roots. Okay, in our session for today, we will be discussing some interesting patterns that are exhibited by square numbers. To study at first pattern, let us list all the natural numbers starting from 1 up to 25. That is 1, 2, 3, 4 up to 25. So in our first pattern, we will count the numbers of non-square numbers that appear between two consecutive square numbers. So let us consider 1 and 4 first. 1 and 4. The numbers in non-square numbers appearing between 1 and 4 is 2 here. 1 and 4 is 2 here. So let us circle the perfect square numbers, that is 1, 4, 9, then 16, then 25. So these are the perfect square numbers. So let us consider first, that is numbers between 1 and 4. So there are two consecutive square numbers, that is 2 and 3 here. Then now let's take a look between 4 and 9. 4 and 9. So here there are two square numbers, and from 4 and 9 there are 4 non-square numbers. So I'll write here there are 4 non-square numbers. Similarly, from 9 to 16 there are 6. 1, 2, 3, 4, 5, 6. There are 6 non-square numbers, as well as from 16 to 25 there are 1, 2, 3, 4, 5, 6, 7, 8 non-square numbers. Generally we can say that there are 2n number of non-square numbers that appear between the squares of n and n plus 1. So that is nothing but this 2. It is a multiple of 2 into 1, and this 2 into 2, 2 into multiple of 2 into 1, then 4 is a 2 into 2, then 6 is a multiple of 2 into 3, and this is 2 into 4. Generally we can say that there are 2n number of non-square numbers that appear between the squares of n and n plus 1, where n is any natural. So n is any natural number. So our next interesting pattern has something odd to do with odd numbers. That is, then I'll take odd numbers starting from 1 and add them in a successive manner. So in first step I'll take 1. In addition to 1 itself is a 1 only. So in second step we add 1 plus 3, that equals 4. Then in third step I'll take 1 plus 3 plus 5, that is nothing but 9. Then in fourth step I'll take 1 plus 3 plus 5 plus 7, that is nothing but 16. So which gives us the 1, 4, 9 and 6 in unit place. So did you notice something particular about the answer that we obtained at the end of every addition? So in fact the answers are, these are the perfect numbers. That is 1 square is 1 here. So this is 4. So this is 9 and this is 16. So these are the perfect square numbers. So every square number can be written as a sum of consecutive odd numbers starting from 1. So let us see some more patterns, some more numbers whose units digit is 0. Then here I'll take some numbers, then square numbers. Numbers and square numbers. So I'll take 10, then 30, 50, 100, 500 and 1000 I'll take. The square of 10 is, that is 10 square is equal to 100. 30 square is equal to 900. Similarly, 50 square is equal to, that is 2500. 100 square is equal to, this is 10,000. It is 500 square is equal to 4. Then this is 25. Then 1000 square is equal to 1, 2, 3, 4, 5, 6. So do you observe any pattern in this square of given numbers? So the numbers of zeros at the end of the square numbers is double the number of zeros here. So here there is only one zero. So here the double of the given 0. So here also single 0 is here, but answer is double zeros here. So double 0. Here there are 2 zeros, but here there are 4 zeros. Similarly, there are 4 here. Here there are 3 zeros, and the answer, so we'll get 6 zeros here. So can a square number has an odd number of zeros? No. No square number can have an odd numbers of zeros at the square of odd numbers. So at its units place. Then we get 2 at the end of its. So for example, 40 square is equal to 1600. So here 1 0 is there. So we'll get 00 in the answer. So let us see some more patterns to understand. So in this model, we will learn the particular square numbers. So let us learn about some square numbers first. That is, I have taken 1 to 10 here. The square of numbers, that is 1 square is a 1. So 2 square is a 4. 3 square is a 9. Similarly up to 10. 10 square is a 100. So observe the unit place here. Observe the unit place. As we see, the square numbers ends with either 0 or 1 or 4 or 5 or 6 or 9 at its units place. Then we'll move on to the square roots. We'll move on to square roots. Move on to square roots. So what is square root? A number whose exact square root can be obtained is called a perfect square. Suppose this is a 16. The square root of 16 is equal to 4. Okay, then square root of 64 is equal to, that is 8 into 8. Nothing but 8. Square root of 81 is nothing but 9 into 9 is 9. So like that. Then we'll see. Can we see some examples? Find the square of So I'll take 59. Find the square of 59. So how to find out the square of 59? That is 59 square. Nothing but 59 into 59. That is nothing but 9 and 81. 25 plus. So 34. 3481 is the answer for 59. The square of 59 is a 3481. Similarly, the square of 15 is, that is 15 into 15, that is 2 to the 25. So 225 is the answer. Let me see. Find the square root of. Find the square root of. This is 14.4 upon 22.5. 22.5, that is nothing but this, we can write it as, so 144. After removing the decimal, I'll write it as 144 by 225. So this is nothing but, so this implies 144. I can write it as 12 into 12. The square of 12 is nothing but 144 divided by the square of 225 is 15 into 15 is nothing but 12 divided by 15 is the answer. Then I'll take one more example. It is 25 by 32 into 2 into 2 integer 13 by 18 into 0.25. 0.25. So let's start. So write this 25 by 32. So this 18 to the 36 plus 49 by 18 into 0.25. This implies, so we can write this one as 25 by 32 into 49 by 18 into this 0.25. I'll write as 25 by 100. So after simplification, so we get, this is 25 ones are 25, 4s are 100. That is 25 by 32, 49 by 18 into 1 upon 4. So this implies, this 25 I can write it as 5 into 5. Then this 49 I'll write it as 7 into 7 divided by 32. Can write it as 2 into 2 into 2 into 2 into 2. Then this 18 I can write it as 2 into 3 into 3. Then this 4 I can write it as 2 into 2. So this 5 25 by 32 into 49 by 18 into 1 upon 4. So this I can write it as, this 25 I can write it as 5 into 5. So 14 I can write it as 7 into 7. So 32, that is 2 into multiple of 5. 5 times you have to multiply, then you will get 32. Then 18 I can write it as 2 into 3 into 3. Then 4. 2 into 2. So that implies 5 into 5 into 7 into 7 divided by 1, 2, 3, 4, 5, 6. So I'll take all 2's one side into 3 into 3 into 2 into 2. That is nothing but 5 into 5 into 7 into 7. So here 1, 2, 3 and 4. There are 4 terms. That is into 3 into 3. Now 5 root of 5 into 5 is nothing but a 5 into root of 7 into 7 is a 7. Then take out the terms. That is 2 into 2 into 2 into 2 into 3. 5 7s are 35 divided by 2 2s are 4, 8. That is 48. So 35 by 48 is the answer. So let's take one more example. I'll take one more example. That is root of 3 square into 6 cube into 24. So this is root of 3 square into 6 cube into this 24. I can write it as 6 into 4. Now this is 3 square into this 6 cube and 6. That is nothing but 6 to the power 4. So this 4 I can write it as 2 into 2. That is nothing but 3 square 6 4 into 2 square. 2 square. So this is 3 into 3, 6 into 6 into 6 into 6. That is 4 times into 2 into 2. So take out all the terms. That is 3 into 6 into 6 into 6. That is 6 3s are 18 into 6 2s are 12. We get the answer. So 216 is the answer. So that's all, students. So homework for you. So solve exercise 3A. Hope you all have understood. Please practice it well and solve the exercise. Thank you.